So when we think about gases, we've discussed in previous lessons how we isolate variables, and we think if we control this, if we control, say, I don't know, temperature, then we were talking about Boyle's law, where we're looking at the dynamics of pressure and volume and how they interact, right? And so we've talked about Boyle's law, Charles' law, we've discussed Gay-Lussac's law. And we were looking at interactions between two of those variables at one time when we were keeping the number of particles constant, and then one of those other variables we were keeping in a constant state as well, and looking at what was the effect on our initial and our change state. But in reality, there's this constant interaction between pressure, volume, and temperature. And so what we want to do is just let's just sort of explore that a little bit here, right? So we had Boyle's law, right? We had Boyle's law, and if you go back, we looked at the fact that Boyle's law, we had this, we came up that pressure times volume, all right, and then when something was kept constant, we had pressure times volume. So remember, P1 V1 equaled P2 V2, right? So then we had Charles' law, Charles's law, right? And then we went from, instead of pressure and volume, we were looking at like volume and temperature. And we saw that we had a different sort of relationship. And we saw that we had, when we were looking at isolating our constant, that we had volume over temperature. And so we had V1 divided by T1 equals V2 divided by T2. Okay. And then we've discussed Gay-Lussac's law, right? And then we kind of saw, we went instead of pressure to volume and then volume to temperature, now we looked at pressure and temperature relationship, and we came up with this pressure-temperature relationship as far as our K value goes, right? Okay. So K equals all of these. K equals every one of these things right here, right? So if K equals this, so any number by itself is that number over 1. So this is really P times V, pressure times volume over 1. So I mean, everything is, we can think of it as a fraction. So this is pressure times volume. So notice that pressure and volume are on the top part in Boyle's law. So right, you just multiply those two together. So now notice where Charles' law is, volume is still on the top, it's on the numerator. So now we have divided by, so now if you think about it, here's volume divided by temperature, right? We've just added in Charles' law. Now we have pressure divided by temperature. Notice that there is pressure divided by temperature right here. So all three of those have been combined into one, because K equals all of those. All right. So now let's think about this. If we have a system, we have our initial, and we have our change system, and then our change system, then that means we have P1 V1 over T1 must be equal to P2 V2 over T2. And right there, there's our combined gas law. So if we can look at the conditions between multiple things changing, where our pressure and temperature are changed, and then how is that going to affect our initial volume? All right, if we know what our new volume is, and we understand what our initial conditions were, we could then look at what initial volume did we have under these conditions that we're observing at some other time, right? It doesn't matter which way you go, it's just a mathematical equation. So, pretty easy video, pretty easy concept. This video is short. Combined gas laws, You know, we've done some problems in previous videos where we solve Boyle's law, where we solve Charles' law, where we solve Guy-Lussac's law. So I will do a video where we also solve for this. But essentially, you would have to know, with any algebraic equation, you have to know every single variable but one, because that one is your x. So all you're doing is literally, you would have to have, so there's P1, V1, and T1, P2, T2, V2, right? So you basically have 6 variables that you're looking at. You would have to have 5 of those. You would have to have 5 of those to then figure out that one. It doesn't matter which one you're missing. As long as you got the other 5, you can figure out that one. All right. So I'll do a video where we take a look at that. I just wanted to give a quick basics, and then I will have another video where we actually calculate this type of stuff out. All right. Hope that helped. Bye.